so here we've got a question about a wrecking ball on a demolition site. So this is a heavy ball. We know its mass is 250 kilograms, okay? And it's pulled back with this rope. It's held by this cable at this point A here. So it's attached to a point there, suspended from this cable, and then it's pulled back using the rope, and then it's let go to smash into an object to destroy it. But the point is, at this moment in time, the ball is held stationary by the tension in this rope, okay? And we've got to try and work out the tension in this cable. So the way we're going to do that is to obviously use what we know about forces. And at this point, because the ball is held stationary, we know that the forces, these three forces, must be in equilibrium, and therefore the resultant force must be 0. So what we've got to do here is we've got to work, first of all, we've got to work out the weight. So the weight is equal to the mass multiplied by gravity. So m times g, and that's going to give us 2,450 newtons. And I've quoted that to 3 significant figures in line with the data that I've used to do the calculation. Okay, now the next thing, we've got these two forces here. We've got the weight, which is 2,450. We've got the tension in the rope, and we can put them into a, as vectors, we can join them up head to tail, okay? So there's the first vector to the left, that horizontal vector of the tension in the rope, and then we're gonna have the vertical vector coming down here of the weight of the ball, okay? And we've joined them up head to tail of this vector, okay? Now, those two forces form a resultant force that will complete that triangle. So that resultant force is coming down here, and I'm going to put a double arrow on that to show that that's the resultant force. All right. So what's interesting about that is when you work out the resultant of these two forces, that resultant force must be along the same line as the tension in this cable here. Okay, so there's your resultant force. I'm not going to draw it the right length, but it's got to line up with the tension in this cable because it's got to be equal and opposite to that in order to cancel out and result in no resultant force on this wrecking ball. So we're going to work this one out, work this resultant force out, and by virtue of that, we know then the tension in this cable is going to be the same in magnitude. So to work this out, we're just going to use Pythagoras theorem, 1,200 squared plus 2,450 squared, and then we're going to square root that, okay? And when you work that out, you get 2730 if you do that to 3 significant figures there, okay? Right, and then the next thing, so we now know this force here, which means we know this force here. So we know that this T now is equal to 2,730 newtons, okay? Because this force has to be equal and opposite to this force. Now, the next thing is we know that the force that we just worked out, this resultant force here, is on exactly the same line as the tension in the cable, as we said. So if we work out the angle between this force and the vertical, or the angle between this force and the horizontal, then we know the angle of this force between the vertical and horizontal, okay? So if we call that angle there theta, it's the same as this angle here, theta, okay? And if we call that angle there phi, it's the same as this angle here, phi. Okay, so this is the angle phi, and this is the angle theta, because that's the angle between this resultant force here and the horizontal, that angle there, and this angle here is that angle there, the angle between the resultant force and the vertical. Okay, so let's work those out. So we're going to use trigonometry. We're going to use these two forces here because we had those given to us in the question pretty much. We know that they're right because this force here is just that times 9.81. So we're going to use tan basically. So tan of theta, if we use this as theta, this is the adjacent, this is the opposite. So that's going to be opposite over adjacent. Okay, so in this first instance here, we know that theta is equal to tan to the -1 of the opposite. So that's 2,450 over the adjacent 1,200. So that's going to give us, if you work that out, so we've got 2450 divided by 1,200, and then we're going to work out use tan to work that out, so that's going to be 63.9 degrees. Okay, so 63.9 degrees. And now if we work out phi, we know that tan of phi is going to be equal to, again, opposite over adjacent, but this time that's the adjacent and this is the opposite. So opposite over adjacent this time is 1,200 over 2,450. So therefore phi is going to be equal to tan to the minus 1 of that. Okay, which is going to give us 26.1 degrees. Okay, so that's going to be 26.1 degrees. So that's that angle. That's that angle. Okay, so there we go.